So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic on study of economic minerals, graphite, magnesite and bauxite. So these are the three very important mineral in the industrial field. That's why we call it as it's an economic mineral, which is very important and very economically. It is very much widely applicable in the various industrial applications, and it is very much useful to economically. It is useful for the industries. So let us discuss these three kind of minerals which are economically very much important in the industrial field. So let us start with this. When you talk about graphite, so graphite is a carbon. Basically, it's a carbon, and its appearance is black, soft, greasy feel, and it has a metallic to dull luster. It has a metallic luster. And if you talk about the economic importance of graphite, so it is basically widely it is applicable. It is hugely used as a pencil lead. So it is used in pencil, it is used in the lubricants, it is used in the refractories. So essential for lithium ion batteries and fuel cells. So it is a material where it is essential for the lithium ion batteries and fuel cells, and used in the production of graphite for high-tech applications. And occurrence here is found in metamorphic rock. So basically it is found in the metamorphic rocks formed from carbon-rich sediments and has a hydrothermal veins. Now appearance here is it appears dark grey to black. It appears dark grey to black in color with a metallic to dull luster. It is having metallic to dull luster, and hardness, when you talk about the hardness, it's very soft material. The graphite is a very soft material. When you measure on the Mohs scale, it has a hardness of 1 to 2. 1 to 2 means it's a very soft kind of mineral. Making is easy to mark surfaces, used in the pencils as a lubrication, slippery and greasy to touch due to the weak interlayer bonding, and electrical conductivity, high electrical conductivity due to free moving electrons in the layered structure. And inertness, if you see, chemically stable, resistant to most acids. So it's chemically stable and resistant to the most acids and bases. Brittleness, if you see, so though soft, graphite is brittle and it can break very easily under the stress conditions. So this is how the graphite looks like. So it is used as a pencil leads, or it is used as a lubricants, or it is used as a lithium battery cell. Now, if you talk about the properties, now graphite is naturally occurring from the crystalline carbon C, and properties of graphite here is structure. First of all, structure. So graphite has a layered structure. It has a layered structure with the carbon atoms arranged in hexagonal sheets. Now, electrical conductivity, it is a good conductor of electricity. It is a very good conductor of electricity due to its presence of free moving electrons within its layers. And thermal stability, graphite is highly heat resistant and it maintains its structure at high temperatures. Lubrications. The weak inner layer forces make graphite a good solid lubricant. And softness, if we see, graphite is soft, slippery due to its layered structure. And chemical stability, it is resistant to the most chemical and does not readily react under the normal conditions. Now, what is the uses of graphite? So first thing is pencil lead. So it is widely applicable in the pencil lead. So the most common use of graphite is in pencils, where it is mixed with clay to adjust the hardness. Because it's very soft kind of mineral here. So clay is used to adjust the hardness here. Now batteries is graphite. In the batteries, graphite is used as a anode material. It is used as an anode material in the lithium-ion batteries, and lubricants used in dry lubricants, greases due to its low friction properties. And refractories are found in high temperature applications like furnace lining and electrodes used in arc furnaces. And electrolysis is due to excellent electrical conductivity, and as a nuclear reactor acts as a neutron moderator in the nuclear reactors, and as a composites found in the aerospace sports equipment due to its strength and lightweight properties. Now magnesite, second thing is magnesite. Magnesite MgCO₃, and magnesite is having a magnesium carbonate. So composition itself, it has a magnesium carbonate, and appearance here is white to grey, vitreous to dull luster and brittle. It has a very vitreous luster or dull luster, and it is very brittle, and the streak of magnesite is white in color. So always remember, whatever color the mineral has by appearance, by its look, but once you make the powder form of that mineral it's called as a streak, and the streak of magnesite is white. Even though it is different color as we have discussed here, the color of magnesite here is somewhat in other color, but the thing is the gray color, and the magnesite of the streak of the magnesite here is white. Economic importance, if you see, primary source of magnesium used in the metal alloys and refractory bricks used in the cement, fertilizers and pharmaceuticals. Occurrence here is found in ultramafic rocks, sedimentary environments and hydrothermal veins. Now these are the different kinds of magnesite. You can see it comes in different colors, depends on the type of the variety, depends on the impurities which are present in that. Now magnesite has a various industrial commercial applications due to its properties like heat resistance and high magnesium content and reactivity. Now refractory industry used in the refractory bricks, linings for the steel making, cement kilns and glass furnaces due to its high temperature resistance. Now magnesia based refractories withstand extreme heat and chemical corrosion. And if you talk about the metallurgical uses, so it acts as a flux. It acts as a flux in the steel making to remove the impurities, protect the furnaces used in the production of magnesium metal through thermal reduction and electrolysis. Now, construction and building materials in this magnesia boards are used as a fireproofing materials in construction, used in lightweight cement and concrete, and improve the durability of this construction industry. In the buildings, it increases the durability of the concrete here. So magnesia boards are used for the fireproofing materials in the construction. Now chemical industry here, so a raw material for producing the magnesium oxide, which is used in the fertilizers, fire retardants and wastewater treatment. So it is used in the magnesium salt production, including the Epsom salts and the magnesium sulfate. So Epsom salt, basically it is used for the plants production, the growth of the plants. So magnesium salts are used as a chemical here for the production of these all salts. And when you talk about the environmental applications here, so helps in neutralizing the acidic soils. It helps in neutralizing the acidic soils in agriculture, and used for the flue gas desulfurization and to reduce the sulfur emissions in the power plants. As a medical and a pharmaceutical uses, so magnesium oxide derived from magnesite is used as an antacid and a laxative, and the paper and rubber plastics industries acts as a filler and stabilizer in the production of paper, rubber and plastics. Ceramics and glass industry enhances heat resistance, durability in the ceramics, specialty glass production and all. Now coming to bauxite. So here this bauxite is very important in the field of aerospace, in the field of industries, because the production of aluminium is out of this bauxite. So the aluminium is a primary ore of bauxite, and this kind of aluminium is basically it is used in the aerospace industries as well as in the different industrial field. So composition here is a mixture of aluminium hydroxide, and the streak of bauxite is white. So here also whatever color it has, like it has a reddish brown earthy texture or a often piezo-like whatever color it has, but finally the streak will be white in color. You can see here the mixture of streak of bauxite is white but can sometimes be discolored, and sometimes it may discolor based on the impurities present in that, like brown, pink or red color it may appear if the iron content it is more in this kind of bauxite. Now appearance is reddish brown, earthy texture, and often it is piezoelectric. Now economic importance, if you see what are the economic importance here, primary ore of aluminium, it is a primary ore of aluminium, essential for transportation, construction and packaging industries, used in abrasives, cement and refractory materials. Occurrence here is found in tropical and subtropical regions as a weathering product of aluminium rich rocks. So this is how the aluminium looks like, not aluminium, basically the bauxite looks like, which contains the aluminium inside. So bauxite looks like red in color, like a red mud or like a red block or red rock, but it contains the aluminium as a primary ore inside. So bauxite, the primary ore of aluminium, has a wide range of applications across the various industries due to its high aluminium content. Now what are the production here? If we see what are the applications of bauxite here, first thing is aluminium production. So aluminium, how does the aluminium is produced? So main source of aluminium here is over 90% of bauxite is used to produce the aluminium metal through the Bayer's process used in the aircraft, automobiles or packaging industries like cans and foils and construction materials. So here aluminium production is basically done from bauxite here, so which is used in the aircraft, used in the automobiles, used in the packaging like cans, foils and construction materials. So to extract this kind of aluminium, there is a process here. So what process? We call it as Bayer's process. So in the aluminium production we have Bayer's process method. So what is the Bayer process here to extract the aluminium here? So Bayer process, in this we have the first step like extraction of alumina from bauxite. So the Bayer process is primary industrial method used to refine the bauxite or alumina, which is then used to produce the aluminium metal. Now what are the steps here as we are talking about this Bayer's process? So in this we have a few steps to produce the aluminium. So first step of the Bayer process here is crushing and grinding. So bauxite ore is crushed into smaller particles and ground into a fine powder to increase the surface area for the chemical reactions here. Now second thing is digestion. So first thing is crushing and grinding, and second thing we have seen here, digestion. So digestion is leaching basically. Formation of sodium aluminate. Now the ground bauxite is mixed with hot concentrated sodium hydroxide and solution at high temperature with 150 to 250 degrees Celsius and the pressure at the 3 to 5 atm. Now third thing is under the Bayer process, the third process here is clarification. So removal of red mud, and the sodium aluminate solution is settled or filtered to remove the solid and the red mud, iron, silica and titanium oxides, and the clarified solution contains dissolved sodium aluminate. And fourth step here is precipitation. So formation of aluminium hydrate. The hot solution is cooled, seeded with aluminium hydroxide crystals in induced precipitation, and the solid aluminium hydroxide is then separated. The fifth step here is calcination. So calcination is formation of alumina. So aluminium hydroxide is heated 1000 to 1100 degrees Celsius in the rotary kilns or fluidized bed calciners. So this was about the Bayer's process here. As the first one we have seen here, aluminium production. So under the aluminium production you have the Bayer's process steps here. So we have gone through this 5 steps to produce the aluminium out of it. Now the second application here is refractory industry. So high aluminium bauxite is used in the refractory bricks and linings for furnaces, kilns, and incinerators due to its heat and corrosion resistance. And the third thing here is abrasives. Now, calcined bauxite is used in making sandpapers, grinding wheels, cutting tools due to its hardness process. So, this is also used as abrasives like in the sandpapers as a grinding wheels or a cutting tool. Now, cement and construction industry used in high aluminium cement for making it durable, heat resistant, and concrete. And bauxite residue or red mud can be used in road construction and bricks. Chemical industry here is used in to produce aluminum sulfate, which is important in water treatment, paper manufacturing process, and textiles here. And also it is used in the production of synthetic zeolites, catalyst, and flame retardants. Now, next thing coming to the petroleum industry. So, bauxite is even used in the petroleum industry, like calcined bauxite is used in the propants for the hydraulic fracturing, or we call it as fracking in oil and gas extraction. And the seventh thing, if you see here, is electrical and electronics industry. It is also used in the electrical and electronic industries, like aluminum derived from bauxite is used in wiring, electrical conductors, and electronic devices. Now, defense here and aerospace here is lightweight and strong aluminum alloys are essential. They are essential in military and aircraft and ships and space exploration. So, basically, it is more important in this defense and more important in this electrical and electronics industry, because all the bauxite, all the aluminium, most of the aluminium, it is used in the wiring and the electrical as the electrical conductors and the electronic devices. Now, lightweight and strong aluminum alloys are essential in military aircraft, ships, and space exploration. So these are the few of the references just you can go through to find out more content about the study of economic minerals of graphite, magnesite, and bauxite. To get the more information, just refer these books to find out the more content about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.